Good morning to all of you. Today we shall discuss a very important concept of pH. pH is an acronym for potence dehydrogen, that is power of hydrogen in German. In order to understand the concept of the pH, we are going beyond the scope of this video and we shall discuss ionic product of water that will help you to understand what is the concept of the pH. We have already discussed an electrolyte. An electrolyte is a compound which in water dissociate to produce ions. Water is a feeble electrolyte, kamzor electrolyte, and it dissociates to produce hydrogen ion and hydroxide ion. At 298 Kelvin, the product of concentration of hydrogen ion and concentration of hydroxide ion is equal to 10 raised to the power minus 14 mole per square per liter square. This is called ionic product of water, Kw. So what is ionic product of water? The product of concentration of hydrogen ion and concentration of hydroxide ion at 298 is known as ionic product of water, and its value is 10 raised to the power minus 14. This is a constant value for this temperature. So water at 298 contains hydrogen ion and hydroxide ion in very low concentration, and the product of hydrogen ion and hydroxide ion in water at 298 is equal to 10 raised to the power minus 14. Now, water dissociates to produce hydrogen and hydroxide ion. These ions will be present in equal concentration. It means the concentration of hydrogen ions is equal to the concentration of hydroxide ion. Therefore, the concentration of hydrogen ion will be equal to 10 raised to the power minus 7 mole per liter. And the concentration of hydroxide ion is also 10 raised to the power minus 7 mole per liter. Ionic product is 10 raised to the power minus 14. So water contains hydrogen ion as well as hydroxide ion. When an acid is added to water, acid furnishes hydrogen ions, and therefore the concentration of the hydrogen ion increases from what 10 raised to the power minus 4 and the concentration of hydroxide ion decreases so that the ionic product of water remains constant. For example, consider that when an acid is added, the concentration of hydrogen ion is increased from 10 raised to the power minus 7 mole per liter to 10 raised to the power minus 6 mole per liter. And as the concentration of hydrogen ion is increased, there will be a corresponding decrease in the concentration of hydroxide ion there, so that the ionic product of water will remain constant, and hence the concentration of hydroxide ion will decrease from 10 raised to the power minus 7 to 10 raised to the power minus 8, so that the ionic product remains 10 raised to the power minus 14. Since this solution contains hydrogen ion in higher concentration as compared to hydroxide ion, this solution would be acidic in nature, and it would turn blue litmus red and it would turn methyl orange red. It means a solution which is acidic in nature contains both hydrogen ions as well as hydroxide ion. Difference is that the concentration of hydrogen ion is greater than the concentration of hydroxide ion. Similarly, when a base is added to water, the concentration of the hydroxide ion would increase from 10 raised to the power minus 7, say 10 raised to the power minus 8. But since the ionic product of water remains constant, there will be a corresponding decrease in the concentration of hydrogen ion, so that the ionic product of water will remain the same. 10 raised to the power minus 7 to 10 raised to the power minus 6, and the hydrogen ion concentration would be 10 raised to the power minus 8 from 10 raised to the power minus 7. So ionic product is 10 raised to the power minus 14. It is clear from this illustration that a solution, whether acid or base, contain both hydrogen ion as well as hydroxide ion. Difference is an acidic solution contain hydrogen ion in greater concentration and a base contain hydroxide ion in greater concentration. On the basis of this fact, a Danish biochemist rather, S.P.L. Soren Peter Lauritz Sorensen, gave the concept of pH. P stands for potence, D hydrogen, that is power of hydrogen ion. pH is defined as the negative logarithm of hydrogen ion concentration mole per liter. And this concept gives us pH always in positive value. The definition of pH is beyond the scope of 10th class. So we are not going to discuss the definition of pH. Now you see, this is the pH scale. On this pH scale, we can measure pH from 0 to 14. At pH 7, a solution contains hydrogen ion and hydroxide ion in equal concentration. And it is neutral, it neither has effect on blue litmus paper nor red litmus paper. Now as we move towards pH 0, you can see there is continuous increase in the concentration of hydrogen ion and there is decrease in the concentration of hydroxide ion. And therefore the solution becomes more and more acidic. A solution with pH 6 is more acidic than a solution with pH 7. A solution with pH 4 is more acidic than a solution with pH 6. You can compare. A solution which has pH 4 has concentration of hydrogen ion equal to 10 to the power minus 4 mole per liter, whereas a solution whose pH is 6 has hydrogen ion concentration of 10 to the power minus 6. Since 10 to the power minus 4 is greater than 10 to the power minus 6, so a solution with pH has more hydrogen ion as compared to a solution with pH with 6. Similarly, when we move from pH 7 to 14, you can see the concentration of hydrogen ion decreases and the concentration of hydroxide ion increases. So a solution with pH 9 will have greater concentration of hydroxide ion as compared to a solution with pH 8. So this is the concept of pH. Thank you.